So first of all, the Common Core. It really is Algebra A, REI reasoning, okay? And then it's part 5, and it says this: given a system of equations given a system of equations in two variables replacing one equation into the other for a sum of that equation, and that's what we're going to do. So it says, given a system of equations in two variables, replacing one equation into the other for a sum of that equation. I'll read it again. Given a system of equations in two variables, replacing one equation into the other for a sum of that equation. Okay? So we are going to substitute one equation into the other. We're going to replace it, right? So here's my method, and I'd like you to do it my way. I really would. Whenever I do substitution, I always write the two equations side by side because I need space to work, okay? I always write them side by side because I need space to work. So I'm going to write off the bat, equation 1, I'll write as y equals x plus 2, and equation 2, I'll write as my x plus y equals 8. And I like to put a line down between, okay? So when I do substitution, I like to write them side by side because I need room. I need room to work on either one or the other equation, right? So I write them side by side and put a little line down the middle to separate them, okay? Now if I'm going to substitute, one of the big keys is this. Like a little star over here on the side. You need one variable solved for, okay? What does that mean? I need it to be y equals blah, 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 or I need something to say x equals blah, blah, blah. You have to have y isolated or x isolated so you can substitute, okay? You absolutely need to. Now the nice thing about the first example is we have that. We've got y equals x plus 2. So I already have a variable isolated. I've got y equals. So what I can do is just take my x plus 2 and put it in for y into the other equation. So when I put that into y into the other equation, we replace it or substitute out the y. So let me rewrite what I have. I have an x plus, but not y anymore, but what y is equal to. And that's my x plus 2. Right? So I just replaced y for what y is equal to in the first equation, x plus 2. So we replace the y with x plus 2. Now I don't need the parentheses because there's not really anything to multiply through. So I can just drop the parentheses. If there was a number here, I'd just multiply it through. So I really have an x plus 2 equals 8. Now I can solve for x. That becomes pretty easy. So I'm going to get a 2x plus 2 equals 8, right? And then I'm just going to keep solving. Minus 2 minus 2. 2x equals 6. Divide by 2, x is 3. So what I have is I only have half the answer. I only have half the answer because I'm really looking for where two lines intersect. They intersect in a point. So my answer has to be some point of intersection. So I've got a 3 something, right? The 3 is the x value, so I got 3 something. What I don't know is the y, but that's pretty easy because I'll substitute again. This time I'll take the 3 and I'll put it up for the x. So I'll just replace, instead of writing x, I'll write what x is equal to. So I substitute into the second equation, and come back and substitute into the first equation. So I'll rewrite this as a y equals a 3 plus 2 because x is equal to 3. 3 plus 2 is 5. So my answer again is a point where two lines intersect, right? We're not graphing, but we do know they intersect at the point 3, 5. That's the answer we want. Okay, pretty easy. Thumbs up. You've done this before, right? You did this in algebra. Should be real easy, okay? All right, example 2. Let's do it again. So again, I've got equation 1, I've got equation 2. So I'll write equation 1, y equals 2x plus 5. And equation 2 will have 3y plus x equals 6, all right? So when I do substitution, again, I like to write them side by side because I need room to work, right? That's why I write them side by side. And then I need one of the two variables to be solved for. Fortunately, I already have it. Y equals, right? I already have it. So this one's pretty easy. I can make my substitution. So I'll take my 2x plus 5 and I'll just put it in for y. So instead of writing y, I'm going to write 2x plus 5 into equation 2. So let's rewrite this 3. But instead of writing y, I make my substitution. 2x plus 5 plus x equals 6. Okay? I need to solve for x. I can do that. I need to distribute 3a times 2x. 3 times 5 gives me a 6x plus 15 plus an x equals 6. That's a 1x. Doesn't look like it, but it is a 1x. So I get a 7x plus 15 equals 6. Minus 15 minus 15. I get a 7x equals, what's that, negative 9 probably. Negative 9. And I get x equals negative 9/7. Now, I like this example because if you were to graph these, you probably wouldn't get this answer, would you? Now, that's the same thing as really, or negative 1 and 2/9, or 2/7, right? So, if you were to graph these, you'd never get this answer, would you? You couldn't get it exact. But by doing it this particular method, you can get it. Now, how do you get the y? Well, we're going to have
substitute.
Yep, substitute. So Will's right, let's substitute. We're going to have to do a little bit of fractions. They don't scare me. I can do fractions right there. I can handle fractions. Y equals 2 times negative 9/7 plus 5, right? Y is equal to negative 18/7 plus 5. See, it goes in 2 times with 4 left over. So the same thing as negative 2 and 4/7. Add 5 to it. And I think I'm going to get y is equal to a 3 and 3/7. Now, there's definitely an answer you wouldn't have gotten from your calculus. So my answer in point form is going to be a negative 1 and 2. Negative 2, and let's go hold it real quick. Did I do it wrong?
You just add 5 to it, so wouldn't it just be 3 and 4/7?
Well, you're subtracting it, right? Negative and positive, right?
Right.
Oh, it should be 2. It should be 2. It should be a 2, not a 3. 2 and 3/7.
No, it should be 3 and 4/7.
Yeah.
Okay, let's see.
No, because he's taking away 2 and 4/7, so it's not there's only part of it.
These calculus don't really do fractions, but there's a way you can kind of get away with it. Math, frac, 17/7. 17 goes in, 7 goes in 17, 2 times, 3 left over. Okay, there we go. 2 and 3/7. Jackson, there you go, huh? Now, okay, one more time. I want to reiterate that you can't get this. You can't get this answer if you can't do fractions, right? But you can't get this answer from graphing it, certainly, right? If you try and graph this, you'd never get this answer, all right? Okay, you guys ready to turn the page? All right. All right, example 3. Okay, let's again side by side. I've got equation 1 is my 2x plus my y equals my 6. And my equation 2 is my y minus 8x equals 1. Now, we cannot substitute yet. Not yet. We have to either say y equals blah, 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 or x equals blah, blah, blah. So we got a couple of choices. We actually have 4 choices. We can solve for y here by bringing the 2x over. We can solve for y here by bringing up the 8x. We could solve for x here, but then we're going to have to divide. That's kind of messy. We could solve for x here, but then we're going to have to divide, and that gets kind of messy. So it really comes down to your preference. Whether you want to bring the 8x over here and have y equals, or whether you want to bring the 2x over here. So what do you like? It doesn't matter, okay? Anybody have a preference? Solve for y in the first one or the second one? Anybody? First one? How many people say first one? Second one? Really? We're kind of divided. Well, I get to choose it. I'm going to go the second one. Because then I avoid negatives, right? Because I avoid my negatives, right? So I'm going to bring over the only because this will divide. This will avoid negatives because I'll go 8x plus 1, right? And then I can take that and plug that in for y, which is right there. So I'll go my 2x plus my 8x plus 1 equals 6. 10x plus 1 equals 6. Fractions again. But this time I might use decimals. I'll show you why. Minus 1, minus 1. I've got 10x equals 5. Divide by 10, divide by 10. X is 0.5. Now, you guys you don't mind decimals. You just hate fractions, right? Agree? So let's go decimals. So if I plug in 0.5 into here, I'm going to rewrite this as y equals 8 times 0.5 plus 1. Now, half of 8 is 4, but if you don't believe me, use your calculator, right? You could always go, okay, Mr. Davies, I cannot do math. I'm just going to use my calculator. That's okay. I'm going to ignore my phone. Okay, so I get 4 plus 1 is 5. So my answer, remember the answer is a point. The answer is a point in xy form. It's going to be 0.5 comma 5. How's that? I sure can, Daniel. Yeah, whoa, too much. Whoa, too much. There you go. Yeah. Yeah, help me out. Now, when I start to go off the page, let me know because I can't see it, okay? Thumbs up on that one? Thumbs up? Thumbs up. Amanda? Okay. Alyssa? Thumbs up? Yep. Okay, was that a yep, you're with me? Aaron's with me. Is Alyssa with me? She kind of with me? Okay, last one. Right? Number 1. (6x plus 3y equals negative 15). Okay, so number 1 is not too bad because y is already solved for, right? So let's take the 8 minus 2x and put it right there. Okay? You heard that? Number 1 is already solved for, so I can make my substitution. So let me rewrite this as a 6x plus 3 times 8 minus 2x equals negative 15. 6x plus 24 minus 6x equals negative 15, right? Oh, wait a minute. Something weird's going to happen. My x's are going to cancel. I can't solve for x if x is gone, can I? And I get this 24 equals negative 15? No. Exactly. So what's happening is these two lines are parallel. We didn't graph them, but they have to be parallel, so no solution. Easy? Okay, page 194, 2 through 5, 10, 17, 18, and 52.